My name is Dr. Sandrine Claus. I work as a lecturer at the University of Reading, and I look at the interaction between the host, metabolism, and the gut bacteria. Microbial medicine is using live microbes to actually modify the balance of the gut bacteria that we have in our intestine to provide a beneficial outcome to the host, which is us. If we think about some common diseases of the intestine, like ulcerative colitis, for example, we know that those diseases are associated with some disturbance of the gut bacteria, and therefore we hope that by modifying the balance of the gut bacteria, we may in the future treat or ease some symptoms associated with those disorders. Microbial medicine is a very challenging but also very exciting field of research today. We are actually looking at another way to do medicine, giving people live organisms instead of drugs. In the future, we may have genetically modified bugs that do produce, for example, the drugs in our gut instead of actually giving a pill. The most exciting applications of microbial medicine are treating diseases that were untreatable before. For example, we have a disease called hyperoxaluria that is a defect in the metabolism of one compound. The consequence is that very often kids that are affected need a kidney transplant and a liver transplant. And hopefully in the future we'll be able to modify bacteria so that we can have better degradation in the gut, so it's not as absorbed as it is in those kids. We hope in the future that the bacteria will be used to relieve some of the side effects associated with type 2 diabetes. Type 2 diabetes today affects millions of people worldwide, and if we were only able to ease those symptoms in 10% of the people, there will be still millions of people worldwide that will have lower side effects. We hope in the future that we will be able to treat or to ease the symptoms of some cognitive disorder, psychological disorders. There are lots of evidence now that autistic disorders are associated with an imbalance of the gut bacteria. There is a very large EU-funded project at the moment called My New Gut. This is a huge consortium of 32 teams in the world who are looking at the interaction between the gut bacteria, obesity and related metabolic disorders, and cognitive impairments. The hurdles that need to be overcome for microbial medicine to progress today are to understand the biological mechanism that underlies the interaction between the host and its gut microbiota. What I do here at the University of Reading is actually looking at the set of small molecules produced by the bacteria that can be absorbed by the host and have potentially an effect on the host metabolism. Another challenge that we're facing is actually to deal with the data analysis, because we are generating huge amounts of data. What's exciting about this research, we have here a reservoir of genes that we can modulate rather than our own genes. Obviously cannot be changed, but we can alter the balance of the genes available in our gut in some way.